Hello, and welcome to this lesson on the converse of the Pythagorean theorem. The word converse means the opposite. So we're actually going to be doing something a little bit different than we've normally done with the Pythagorean theorem. In the past, we've been given a right triangle, and our job would be to find one missing side, something like that. But part of that rule is you had to have a right triangle. Well, the goal of the converse is if I'm giving you some other triangle and I give you all three sides, we'll be able to figure out, is this a right triangle? Yes or no, because the Pythagorean theorem only works on right triangles. Okay, the central question says, how do I apply the converse of the Pythagorean theorem to learn about triangles? Did you know that one of the best uses of the converse of the Pythagorean theorem is actually in carpentry? So when you're making a door frame or a window frame for a house, you need to make sure that it's a perfect right angle, or your door won't open and close, or the windows won't work right. So kind of look around the room you're in right now and look at all the different right angles. Perfecting the right angle is only possible thanks to this Pythagorean theorem. I mean, if you measure this and measure this and measure the diagonal, it makes this a perfect right angle. That's how they used to do it a long time ago, before kind of some of the more fancier carpentry tools, is they would actually just measure, and do the math real quickly and get themselves an answer. So some vocabulary here. We already know the Pythagorean theorem. We should be deep into our knowledge of the Pythagorean theorem now. We've done a couple pretty in-depth lessons, so that we've used a whole bunch of times. We know that the C is the longest side, the hypotenuse. So our two new words, we have an obtuse triangle and an acute triangle. An obtuse triangle is just a triangle where the largest angle is an obtuse angle. So an obtuse angle, in case you forgot, is an angle that is open wider than 90 degrees. It's open more than a right angle. So it's usually, I think of it as a big wide open. So that would be an obtuse triangle. Where an acute triangle is a triangle where the largest angle is acute. It is less than 90. So we'd be thinking of this guy might be 110 degrees, and the one down below might be 53 degrees. Might be the largest angle or something. Which I guess it's hard to be the largest angle at 53, but it's okay. We'll ignore him for now. So our goal is going to be figuring out, is the triangle we're looking at a right angle, a right triangle, an acute triangle, or an obtuse triangle? And it's really not that bad. So directions say, determine if each triangle is acute, right, or obtuse. So the way we're going to do this is we're going to take the triangle they give us. Most of the time, or a lot of the time, they're not going to give us a picture. We draw our own. So I just draw something that looks kind of like a right triangle. I don't focus on the side lengths. I just draw a triangle. Okay. Now, when you're plugging the numbers in, when you're labeling your picture, you have to make sure that the longest side always goes in for the hypotenuse. So here, my longest side is, well, one of these sixes. 6. The other two, 5, 6, you just kind of plug in. Those are our legs. And that's where I'm assuming the right triangle is. I don't actually know if this is a right triangle, okay? But I'm putting the thing there so we can see that that one would be the hypotenuse. Now, all we do is our Pythagorean theorem. A squared plus b squared equals c squared. Plugging in our sides, 5 squared plus 6 squared equals 6 squared. I made sure, well, it's hard to tell, but this side is the one that goes in for the c because that's the hypotenuse. And then let's see, what is 25 plus 36? I'm skipping a little bit of work in my head. That's 25, that's 36. So this side, if we add together, we get 61. 6 squared is 36. And this did not work out. So we are not missing a side. We know all three sides, but check this out. When I plugged in all three numbers and I did the math, look at this. I got 61 equals 36. which is not true. So this is not a right triangle. I can guarantee you that because the math did not work out. It is not a right triangle. But we can actually go a little bit farther. We can actually tell what type of triangle this is by looking at its hypotenuse. So if the hypotenuse is too big, we would have an obtuse triangle. If the hypotenuse is too big, it makes your biggest angle too big. If the hypotenuse is too small, well, now you're looking at an acute triangle. And if your hypotenuse is just right, well, you get yourself a right triangle. So in this case, our hypotenuse, our longest side, was too short. He did not equal up to the 61 when we did all the math. So the hypotenuse was too small. This is an acute triangle. There, acute triangle. So that's it. We're going to take the three side lengths, we're going to plug them in to the Pythagorean theorem, do the math, and then based off of this final step, we're going to determine if the hypotenuse is too big. If this was, say, like a 95, well, then the hypotenuse is too big, we would have an obtuse triangle. If the hypotenuse is too small, it means instead of having a 90-degree angle, our angle is too small. It's an acute triangle. And if the hypotenuse is just right, well, then we have a right triangle. So letter B. Triangle XYZ has side lengths of 5, 12, and 13. So again, I just kind of draw just a random triangle. 5, 12, and I made sure I put the longest side in for the hypotenuse. That is the hypotenuse over there. So a squared plus b squared equals c squared. I plug the longest side in for c and the other two in for the other two. 5 squared is 25, that's 144, so 25 plus 144 is 169. 13 squared is, well, would you look at that? That worked out perfectly, where the a squared plus b squared did equal the c squared. That must mean this is a right triangle because the math, the Pythagorean theorem, actually worked here. And the Pythagorean theorem only works on right triangles. So this is a right triangle. Okay, so we've seen what happens when you get a right triangle. We've seen what happens when you get an acute triangle. Maybe the next one will be obtuse. I don't know. So why don't you go ahead and, well, pause the video and do this one right now. I'll leave this up here on the screen so you can refer back to it if you need to. So draw your picture, label your parts, do it. When you're ready to continue, hit play, and we'll go through it all together. All right, let's see. Boom, 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 triangle. Plug the longest side in for the longest side, the other two for the other two, and then we go to town. A squared plus b squared equals c squared. 10 is your longest side, the 8 and the 6 are not. 8 squared is 64, plus 6 squared is 36, gives me 100, and that's 100, I know. So this was another right triangle. The math worked out. It was just right. This side equals this side. The hypotenuse was just a perfect size to make this work. I'm going to copy this just in case I need them further down below, because that little chart thing's kind of like the whole, it's a summary of the whole lesson, essentially. There, we'll hide them down here. All right, triangles DEF with side DE is this, EF is that, and DF is that. Is this triangle acute, right, or obtuse? How could you change this triangle so that it is a right triangle? Okay, so here's what I want you to do. I want you to get to the first part. I want you to figure out if this triangle is a right, acute, or obtuse. and then pause, and then we'll actually talk about the second part here together. All right, so longest side is over there, so I'm just going to call this side D, E. That would make him an F. So DE is 18. EF is now 12. And DF is now 7. Again, I draw the right angle box down there, but I don't know if it's actually right angle. I'm putting it there so I know that the one opposite is the hypotenuse. That's the longest side. Okay, a squared plus b squared equals c squared. 18 is over here. 12 squared plus 7 squared. I know this is 144. I know that's a 49. If you don't, I guess you could have been just 12 squared plus 7 squared. 193. And on the other side, 18 squared is 324. So this is obtuse. It is very obtuse. My hypotenuse, my longest side, is way too long. So this is an obtuse triangle. Actually, I'm going to move him because I don't want the answer there. I need that space for work. So there's the first part of my answer. It is obtuse. And hopefully you found that to be true as well. Now, the second part of the question says, how could you change this triangle so it's a right triangle? Okay, so we know that these three sides in this combination doesn't work. All we would need to do is change one of the sides to make it work. So this is a lot easier than some students try to make this out to be. All you got to do is just say, okay, you know what? I'm going to get rid of that 18. I know the 18 didn't work, but I'm not quite sure what it should be. We know how to do this math. We know how to find the correct side length here by using our Pythagorean theorem. So a squared plus b squared equals c squared. I'm going to use x as my hypotenuse because that is the longest side of what I'm now making it a right triangle. 7 squared plus 12 squared. And actually, I can cheat this a little bit because I already know what this math is because I did it up here. So that's 193 equals x squared. And then to do this problem, I would square root both sides, and we get x equals the square root of 193 is 13.89. There we have it. If this side was 13.89, it was a right triangle. So originally when it was like 18, it was way too big. That's what made it an obtuse triangle. This longest side would be so long, maybe like this, that the other two sides would be kind of like that, because this side was way too big. So I guess my second answer is, well, that. And I was just checking there's no units because it's just kind of a triangle with side lengths. All right, moving on. A carpenter is framing out a doorway, and he wants to know if the door is a rectangle. The height of the doorway is 84 inches tall. The width of the doorway is 35 inches wide. Okay, I'm already going to draw a picture because, well, pictures are good. So I'll squeeze it in here. So the height is 84. The width is 35. He measures the diagonal distance of the doorway and finds it's 90 inches long. And that is 90. Now, in a doorway, we are assuming that this would be a right angle. We don't know. That's kind of the whole point of the question, is we want to see if the door is a rectangle. The thing that's special about rectangles is they have right angles. Let's see, he measured the diagonal distance is 9 inches long. Is this doorway in the shape of a rectangle? Is this actually a right angle? If the answer is yes, it's a right angle, then all of these would be right angles. If the answer is no, this is not a right angle, well, then we have a problem. And the second part would be, well, how long the diagonal distance have to be to make it a rectangle? Well, same thing, like if this is a rectangle, we'd say, well, we don't change a darn thing. But if this is not a rectangle, then we can figure out how far we'd change this. All right, so I'm now going to bigify my picture because I have more space. So let's do it. So, well, a squared plus b squared equals c squared here. Let's do hypotenuse. And then 35 and the 84. I'm definitely not doing that math in my head because I can't. 35 squared plus 84 squared is 8,281. 90 squared, I can actually do that math in my head. That's 8,100, but I'll double check it. It's early in the morning. There you go. So I can tell you right now that this angle here, because this is too small, that makes this an acute triangle. So the triangles, now I'm going to over exaggerate this. There, that would be like our doorway, where that angle, instead of being a right angle, is an acute. It's too small. It's kind of shrunk down a little bit. So we know it's now an acute triangle. The second part of the question was, well, how would we change the hypotenuse to make it a right triangle? If that 90 is wrong, we need to like tilt it or something, our doorway, to fix it. What would that 90 have to be? And that's a pretty easy thing to do as well, because all we do is say, okay, well, I know that 90 is wrong. Let's put an x in there. Let's figure out what that is. And we just do Pythagorean Theorem a second time. This is very similar to the previous problem, where now my hypotenuse is an x, and there's my 35 plus 84 squared, and I'm cheating looking at this math over here because I already did it. That's 8,281 and x squared. And then when I square root both sides to get rid of my x squared, to make it just plain old x, we get the square root of 8,281 is 91. So if the hypotenuse, or if the diagonal, is 91 inches, it's a rectangle. Say the door is a rectangle. All right. So that's the whole problem. That's the whole kit and caboodle. We figured out it was an acute triangle by plugging in all three original sides. We then changed our hypotenuse by making it just an x and doing the math to figure out how big it should be. If this was a 91 instead of a 90, the door would be a rectangle. All right, let's see. Here's one for you. So why don't you go ahead and pause the video and do this problem on your own right now. When you're ready to continue, hit play and we'll go through it together. All right. Side lengths of a triangular yard are 30, 40, 50. I'm putting the 50 where the hypotenuse would go, and then the 30 and 40 on the other two. And then we go to 10. Longest side goes in for the C. The other two sides go in for the other two sides. Oh, I could actually do this math. That's 900 plus 1600 equals 2,500. And I know that this math is going to work out. That's 2,500 and 2,500. And I knew that because when you are familiar with right triangles and Pythagorean Theorem, you've done a bunch of these, you're going to start seeing patterns a lot. There is a couple Pythagorean Theorem triples. They're called Pythagorean triples, like three numbers that make a right triangle in the Pythagorean theorem. Things like 3, 4, 5 is Pythagorean triple. 5, 12, 13 is Pythagorean triple. Those are probably like the most common two. Well, the problem we have right here, this is a 3, 4, 5 triangle. It's just 10 times bigger. If you times each of them by 10, you're going to get a 30, 40, 50 triangle. So I could tell from the beginning that this was going to be a right triangle. And I'll be honest, I think one of the other triangles we had up above was a 5, 12, 13. Not this doorway problem. Not that problem. Oh. There's a 5, 12, 13. This is actually a 3, 4, 5 times by 2. 3 times 2, 4 times 2, 5 times 2. So they're hidden. You don't always see them, but those are very, very common right triangles. So this is a right triangle. Answer. Letter C. Would an equilateral triangle be an acute, right, or obtuse triangle? Well, equilateral means equal sides. So if I had a triangle, boom, 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 with equal sides, 5, 5, 5, all the sides have to be the same. Would this be right, acute, or obtuse? Let's see. 5 squared plus 5 squared equals 5 squared. Like I can tell already, there's no way that this side is going to equal this side. Because over here, I've got 25. On the left, I've got 2 25s. I've got 50 equals 25, which just doesn't work. So this is definitely, my hypotenuse is way too small. Wait, I still have the thing. Paste. There he is. My hypotenuse is too small, which makes this an acute triangle. And as far as the y, and that's why, because the hypotenuse is too small. The a squared plus b squared did not equal c squared. All right, this is the last question. See, summary. You are going to draw 3 triangles. Triangle ABC is going to be an acute triangle. Triangle LMN is going to be a right triangle. And triangle RST must be an obtuse triangle. I want you to use the converse of the Pythagorean theorem to show that each triangle is what it's supposed to be. So like, I want you to draw an acute triangle and then do the converse to show it's acute. Draw a right triangle and do the converse, the Pythagorean theorem, to show me it's a right triangle. Draw an obtuse triangle and make sure you have all the sides labeled. Do the Pythagorean theorem and show me it's obtuse. Okay? Go ahead and pause the video and do that right now. All right. If you were paying attention, like, I don't know, about a minute or two ago, the right triangle might be very easy, because if you were paying attention, I was telling you that a 3, 4, 5 triangle is a guaranteed right triangle. And so a squared plus b squared equals c squared. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25, and that works out. So that's kind of what I was expecting for each of the 3. You draw it, you do the Pythagorean theorem to show me that those 3 side lengths are the thing you say it should be. So this was a right triangle. An acute triangle. Well, a guaranteed acute triangle from earlier in the lesson would be an equilateral triangle, something with all 3 sides the same. So how about that? 7, 7, 7. A squared plus B squared equals C squared. 7 squared plus 7 squared equals 7 squared. 49 plus 49 equals 49. 98 equals 49. That is too small. This is an acute triangle. Two down, one to go. Obtuse triangle. To make a good obtuse triangle, all you really do is, I come up with two smaller sides first. This is the strategy I use. So let's say like 5 and 7. And then I make this number just a little bit less than these two sides added together. So these two sides added together would be 12. I'm going to make this, I'm not even sure if 10 will work. 11 would definitely work. We'll try 10. We'll see. So when I do my Pythagorean theorem, a squared plus b squared equals c squared. And this is like the whole point, is like sometimes you might have picked side lengths that didn't work and you just have to fix it. Okay, now I can see that this will work because these will not add up to 100. That's 74. This side is too big. So this is an obtuse triangle. Okay, so I made one of each and I did the work to prove it. The hypotenuse was too small, it was acute. The hypotenuse was just right, it's a right triangle. The hypotenuse was too big, it was an obtuse triangle. So for the summary, can you write for, it says 2 minutes, a couple minutes, about what you've learned from triangles using Converse the Pythagorean theorem? Like, what can you learn? What can you figure out using the converse of this Pythagorean theorem, the thing we learned in this lesson? Okay, I'm not going to write for 2 minutes because you don't need to watch that. But I give you a little summary. The whole point of the thing is, well, you can figure out what type of triangle you're looking at. Based on the 3 side lengths, I'll just use this picture here, you could figure out if the thing you're looking at is a right triangle, an acute triangle, or an obtuse triangle by looking at the hypotenuse. If your hypotenuse is too big, if your hypotenuse is too big, you have an obtuse triangle. If the hypotenuse itself was too small, you would have an acute triangle. And if the hypotenuse was just right, if the two sides actually equaled, if the Pythagorean theorem, the math works out, you are looking at a right triangle. So that's the main goal of what you can figure out using the converse of the Pythagorean theorem. Thank you so much for watching this lesson, and until next time, toodles.